Okay, now let's look at graphing absolute value functions with just horizontal and vertical translations, which is the fancy word for saying shift. So just like with parabolas, what is inside of the absolute value, just like for parabolas, what was inside the parentheses, is going to tell us what's happening left or right, and it's going to do that. It's going to tell us the opposite of what we're actually supposed to do, because inside is part of this super secret opposite society. So what we need to do on this first one, on example A, is we need to say, okay, well, that +1 on the inside, positive for x is to the right, but we need to actually go the opposite, which is left. So this is going to just be a good old shift left 1. And the way we graph this, I realize I could have been vague on this on the last one as well. Like the way we choose to graph this is either we make a table of values, or we say, I know what the parent graph of this looks like. It's a V that goes up 1 over 1 out from the vertex, which is at 0, 0. So we can think about that parent graph and then say, well, let me just shift everything over to the left one. Your comfort with that is going to be based on like how easy it is for you to go, okay, here's the parent function, and I know what to do because of the formula, so let me just do that. What I mean by that is if I know what the parent function looks like, and I'm going to just do the dots to represent, this is what the parent function looks like. I just need to shift each of these points to the left, one spot, and I will have this absolute value graph. So each one of these just moves to the left. And you don't have to graph the parent function first if you have it like, if you have your notes in such a way that you can just look at the parent function that we did on the first day of this week. That might be super helpful. But you are welcome to use a table of values if for whatever reason that seems like it makes more sense to you. So B is a +1 on the outside, so that's a shift up of 1. Okay, so this original absolute value graph that I put on part A, I can think, okay, if I start with those blue dots and then I move them each up 1, what is that going to look like? Well, it's going to move this here, and then since we don't have any vertical stretches or shrinks, we're not going to end up with the slope of these lines different, because that's what affects whether this goes, up 1 and over 1 versus some other rise and run. This last one has 2 things. So inside this -3, negative for x is left, so we want to do the opposite. We want to shift right 3. And then the -4 on the outside, we're going to shift down 4. So right 3 and down 4. And then just go up and over 1 each direction with symmetry and stuff. And voila! I'm trying to make this as easy as possible. It's very understandable if this does not seem easy to you. This way of graphing where we talk about parent functions and then shifts and stretches and shrinks is helpful because all functions work this way. And so we've learned 2 things this year, parabolas and absolute value graphs that work this way. And then when we come back and are in Algebra 2, we're going to look at a whole bunch of other functions that also work the same way, so that it actually may end up feeling like really repetitive every time we go over it, that it's the same thing. But also, it's nice that it's the same thing. That's one of the great things about math. It's consistent. Thanks for watching. Bye.